All right, so here we're going to talk about 3 different applications for using determinants. The first one is for the area of a triangle. All right, so if you're given the area of a triangle and you are giving these as vertices, the one thing to know with this, let's just go ahead and label all of the different pieces that we're talking about here. Any of these points are x1 and this is y1. My second point, we're going to label that x2 and y2. And my third point would be x3 and y3. Now we need this because the formula for the area of a triangle is equal to plus or minus 1/2 of whatever the determinant is of all of the different coordinate pieces. x1, y1, x2, y2, and x3 and y3. Now, it's really important to note that this last column here, this is always 1. Always 1. So to solve this, all I'm going to do is take these points that I have, those points that were given, and the area of this triangle. So what this gives me is that this area of a triangle, now this plus or minus is only determined at the end based upon what the sign of the determinant is. You always want it to be positive. You could use this. So we go ahead and put the values in for all of our points. My first point here is 0, 0. My second point here is 10, negative 25. And my third point is 28 and negative 20. Remember this last column being all ones. Now I'm going to go ahead and do this with the idea of diagonals. So I'm going to copy over my first 2 rows. So that gives me 1, 10, 28, and 0, negative 25, and negative 20. So to go ahead and do these for the diagonals, recall what I'm going to go ahead and do is I'm going to add these going down, the products of all of these. So 0 times negative 25 times 1 is just 0. Same thing with 0 times 1 times 28. That's still 0. And then the last one, 1 times 10 times negative 200, just gives me plus that negative 200. Now I'm going to subtract going up. So I have 28 times negative 25, but I subtract that, so that's going to give me a minus a negative 700. This next one, 20 times 1 times 0, is just a 0. And that last one again is minus 0. So the area of this triangle is just going to be 1/2 negative 200 plus 700. Now, because the inside of this is a positive 500, I want to take the positive of that. So the area of this triangle is just 250 square units. All right, another application of a determinant is this. We are going to find the equation of a line that goes through the points negative 1, negative 4, and 1, and 3, and negative 5. All right, so the formula that we want to use here is x and y. Now, x1 and y1 and x2 and y2, last column being all ones. Now, it's important to see with this formula that as I'm using this first point here gets replaced here, and my second point gets replaced here, but this x1 and y, this x and y stay as x and y. So let's go ahead and bring all of this down and put all my points in. So I have my values of x, y, 1, negative 4, 1, and 1, and 3, negative 5, and 1. I'm going to do the same idea with the diagonals here. I'm going to copy over the first two columns. So that is x, negative 4, and 3, y, 1, and negative 5. So as I'm going to go through and you do the diagonal technique again. I multiply going down. So that gives me x plus multiply y times 1 times 3 plus 3y plus 20. I'm going to go ahead and subtract going in the opposite direction. So then I'm going to go ahead and subtract 3. Subtract a negative 5x. And then the last one I need to go through and do is subtract a negative 4y. Now the key with this is now you to let all of this equal 0. So what do I have here? I have x plus 3y plus 20 minus 3 plus 5x plus 4y is equal to 0. If I combine my x terms, I have 6x. I combine my y terms, plus 7y. And then I combine my constant terms, so this becomes plus 17 is equal to 0, or in standard form, 6x plus 7y is equal to negative 17.